Good morning, everyone. I am by name Tairu Saka, a student, but now a graduate of chemical engineering from Department of Chemical Engineering, University of Maiduguri. Though this may serve as my first tutorial, of which I wanted to solve a question with number 2.7, and this is the question above. And the question says that we should determine the activation energy and frequency factor from the following data: that the rate constant in minute has been given, and likewise the temperature has also been given. And they say that we should use the Arrhenius equation to find the activation energy, and likewise B, if the temperature dependency of the reaction has been stipulated by transition state theory approximated by the following expression, that the equation K naught T karakan, where K naught is the frequency factor and N is constant, which has been given to they say that we should use 1. And what is the percent difference between the value of the activation energy obtained from the equation above? And likewise, we should plot K as a function of T over the range of 100 to 400. Comment on your plot. And although for this question, to at least minimize time, we are going to only solve for A and B, and later on we are going to see for the C and the D as well. Now let me take the data. They say that K and likewise the temperature. They say that the K is 0.001 and that 0.05, while the temperature is at 0, which is in degrees centigrade, where this is a minute, is 100. Now they say that we should find the activation energy, and K naught as well. Now we know that Arrhenius equation is given to be K to be equals to K naught E raised power of minus capital E all over RT. That's the generalized equation for it. Now we know that for us to solve this, since we are having almost up to 2 values, we are going to say that based on now we have almost we have 2 methods where we are going to solve this problem. We can solve it using the graphical method, and likewise we can solve it using the analytical method. But in this case, to minimize time, we are going to use the analytical method. Now, what we are going to do for this equation, this is the general form of the equation. Now, for us to do this, we are going to say that, okay, if we consider our K1, upon considering the other K1, now what we are going to do is that if we presume that K1, since we have to this in rate, we are saying that K1 is equals to K naught E raised power of minus capital E all over RT1, and likewise that of our K2 is equals to K naught E raised power of minus E all over RT2 as well. Now, if we try to take the ratio, just like the percent differences, we know that our K1 by K2 is equals to what? It's equals to K naught E raised power of minus capital E all over RT1 division by K naught E raised power of minus capital E division on RT2. And this, when simplified, it may be equals to E raised power of E all over R open bracket 1 all over T2 minus 1 all over T1 upon indices when you have tried it correctly. Now, our K1 has been given. Our K1 has been given from the question to be our K1 has been given as well. Likewise, our K2 has also been given. Now, what we are going to do is that we need to convert the temperature into what? Kelvin. Now, for us to, I said that we need to what? Convert this temperature into Kelvin, whereby we are going to say that that's 0 degrees plus 273 to give us 273 Kelvin. That's for our T1, while T2 is 100 plus 273, which will give us 373 Kelvin. Then we are going to say that our K1, which is given to be 0.001 divided by 0.05 is equals to E raised power of capital E all over R open bracket 1 all over our T2, which is 373 minus 1 all over 273 as well. But also our R is the same as 3.8 is the same as 8.314, so that after dividing 0.001 by 0.05, we are going to have 0.02, which is equivalent to E raised power of our E, which is unknown, all over 8.314 open bracket then we are going to say that we are going to simplify this as well. We know that 1 division by 373, we are going to have value as 0.0026 minus 1 divided by 273, we are going to have value like 0.0036, so that this 0.02 is equals to E raised power of capital E all over 8.314 open bracket. Then after minusing this, we are going to have something like 0.0011. Then from here we can say that this is the same thing as something like this. Then we are going to say that 0.02 is the same thing as E raised power of after dividing this 0.001 by 8.314, we are going to have something like 0.00, almost up to 4 zeros before 13 of capital E. Now with what? Negative, with minus. Now from here, for us to simplify this, we are going to what? Take ln of both sides. Then after taking the ln of both sides, we are going to take the ln of both sides to cancel this epsilon, to cancel this exponent. Then from here we are going to say ln of 0.02 to be equals to this ln of this will be what? Will just be equivalent to minus 0.00013 E. So that the ln, our ln of 0.2 is equivalent to minus 3.91 by neglecting some of the some of the number after the decimal point to be the same as minus 0.0 minus 0.00 almost up to 0 E 13. Then this minus will cancel this. Then from here we may say that our E from here we may say that our E is equals to 3.91 divided by 0.00013. Then dividing this by minus 0.000 then 13, we are going to have something like 3,092.5. This implies that our activation energy is 30,092.5 kilojoules per is joules per mole. Is 30,092 joules per moles, and which may be regarded to be this thing. Then from this activation energy we can substitute it in any of the equation. Maybe from we should assume this equation to be our equation 2. Then substituting this into this equation, we are going to find the exact what K naught. Then so that now for us to find K naught, but K naught we may just say that our K1 we know that is equals to K naught e raised power of minus capital E all over RT1, and we know that K1 has been given to be 0.001 and K naught is unknown, while E raised power of minus E all over what? All over RT1. Now this 0.001 divided by E raised power of minus capital E all over RT1 is the same thing as our own K naught. So that our K naught is equal to 0.001 division by what? E raised power of 30,092.5 over 8.314 times our T1, which is 273 Kelvin. So that our K naught is equal to 0.001 division by 30,092.5. We are going to say that 8.314 times 273. We say that 30,000, there is minus here. We are going to minus 30,092.5 divided by 2,269.7, so that our K naught is equal to 0.001 all division by E raised power of minus 30,092.5 divided by 2269.7, which will give us 13.3. So that the exponent of minus 13.3